Okay, this is the video Evidence of Climate Change. We're going to go over the different evidence we see happening in the world around us right now that shows the climate is changing. This is all coming from the Global Climate Change website from NASA. So this is the website where we have lots of basically the facts. They spell it out really clearly, and we'll be going through evidence. We've gone through causes. Future classes, we're going through effects. So, to start with, the evidence for rapid climate change is compelling. First of all, the sea level rise. Global sea levels rose about 17 centimeters from the last century. The rate in the last decade, however, is nearly double that of the last century. So, the sea level has risen almost 20 centimeters, 17 centimeters, and that rate has increased. In our notes under sea level rise, the sea level has risen 17 centimeters in the past 100 years. The rate of change is increasing. Now, some of the evidence that NASA gives on their site is this graph. This is the measurement graph of different sea levels, and currently the rate of change is 3.18 millimeters added to the seas every single year. Right, further down we see a similar graph. Okay, the second bit of evidence we're going to go over is the global temperature rise. So all three major global surface temperature reconstructions show that Earth has warmed since 1880. Most warming has occurred since the 1970s, with the 20 warmest years having occurred since 1981, with all 10 of the warmest years occurring in the past 12 years. Even though the 2000s witnessed a solar output decline resulting in an unusually deep solar minimum, surface temperatures continue to increase. In other words, the sun is inputting less than it used to, but surface temperatures continue to increase. Now you see these little numbers here, 5, 6, 7. If you go to the website, climatenasa.gov/evidence, you can click on those little links if you want to see where they're getting all of these numbers from, all of these facts and figures from. Now the latest measurement was from January 2014, and at that point the average temperature increase was 0.68 degrees Celsius. And here's a graph of the temperature basically over time. And we are sitting up here. You can see the trend of this graph is upward. This is a map that includes all of NASA's data. The data goes back to 1877 when people were taking measurements and writing them down in log books, but they were doing it all over the world. And so taking that data and mapping it, this is what has happened to the global temperature over the past 100 and some years. It starts off pretty cold. The blue areas are where the Earth is cooler than the average, and the red areas are where the Earth is warmer than expected. As we get into the 80s and 90s, we see more and more and more red areas. So as I pause it here at 2013, the top of the world here is much warmer, about 2 degrees warmer than it was at the average, and there's very few pockets that are below average at this point. Alright, so in our notes, global temperature rise, the Earth has increased in temperature by about 0.7 degrees Celsius over the past 100 years or so, and the top 10 warmest years have all occurred in the past 12 years. And depending on how this year pans out, this year might be the top 11 years have been in the past 13. We're stacking up the records. Moving on. Warming oceans. The oceans have absorbed much of this increased heat, with the top 700 meters of ocean showing warming of 0.3 degrees Fahrenheit since 1969. Okay, there's one point I want you to add in your notes here. Besides that, oceans have absorbed much of the heat absorbed by the Earth, And warming oceans are less dense, so those molecules are spread out a little further, and because it's less dense, it's going to cause the sea level to rise. This is what's going to cause most of the sea level rise over our lifetime. Okay, the next two get grouped together. Shrinking ice sheets. The Greenland and Antarctic ice sheets have decreased in mass. Data from NASA's Gravity Recovery and Climate Experiment show Greenland lost 150 to 250 cubic kilometers. That's kilometers the size of a cube, or cubes the size of kilometers on three sides, of ice per year between 2012 and 2006, while Antarctica lost 152 cubic kilometers between 2002 and 2005. So this is the ice that's sitting on top of the Greenland and Iceland, but also there's ice sitting in the Arctic Ocean, so declining sea ice. Both the extent and thickness of Arctic sea ice has declined rapidly over the last several decades. So Greenland and Iceland are quickly losing ice. The Arctic Ocean has much less ice than it used to. Okay. Glacial retreat is the next bit of evidence that we have. Glaciers are retreating at almost everywhere in the world, including in the Alps, Himalayas, Andes, Rockies, Alaska, and California. Alpine glaciers are getting smaller and smaller. Pretty simple. Up next, we have extreme events. The number of record high temperature events in the United States has been increasing, so more record highs, while the number of record lows has been decreasing since 1950. The U.S. has also witnessed increasing numbers of intense rainfall events. So these extreme events, more record highs and less lows, and more frequent heavy precipitation events have been happening. And like I said before, if you want proof of all this, click on these little links and it'll take you to the evidence that we have. So, up next is ocean acidification. Alright, just a reminder, we're going through all the evidence of things that are already happening in climate change. Since the beginning of the Industrial Revolution, the acidity of surface waters has increased by about 30%. The increase is the result of humans emitting more carbon dioxide into the atmosphere and hence more being absorbed into the oceans. The amount of carbon dioxide absorbed by the upper layers of the oceans has increased by about 2 billion tons per year. Ocean acidification. Acidity in the ocean has increased by 30%, and we should note, how does it affect coral reefs? Well, this is why coral reefs are dying off, in short. Up next we have decreased snow cover. So satellite observations reveal the amount of spring snow cover in the northern hemisphere has decreased over the past 5 decades, and the snow is melting earlier. So the amount of snow cover has been decreasing. Less snow cover means less reflected light and more heating. This is an important point. Less snow cover, so if there's less snow in Minnesota, less snow in Canada, means that more sunlight will be able to stay and warm the earth up more. Whereas when there's snow on the ground, that a lot of that light is reflected right back into space. Now the last bit of evidence that we have is at the very top of this webpage. It's this graph right here. This is what's known as the hockey stick graph. Now, for 650,000 years, atmospheric carbon dioxide has never been above this line, this gray line. Okay? And we know this from ice samples. There's ice cores from Antarctica, they're from Greenland, and they all pretty much agree that, okay, atmospheric temperatures have always been, atmospheric carbon has always been about this level. And if we measure that and compare it to today, we end up seeing a spike in this graph, and we're up to 400. And, well, what I want you to know is this. Atmospheric carbon dioxide has spiked over the last 100 years. And what you may want to do is draw a graph. So here's carbon dioxide. Over time, this is 600,000 years ago, 400,000 years ago. This line should actually be going up and down a little bit. But the point of the graph is the end. When we get to today, it jumps straight up. That's why it's called a hockey stick graph. It shows normal variation, then at the end it jumps straight up. So carbon dioxide increases today. So this video covers all of the different evidence we have of climate change happening today, this year, and why